Now today's class is the continuation of binary operation. For problem number 3, let a equal to q minus singleton 0, where q is the set of all rational numbers. Let's start from a cross a to a be defined by a star b equal to 3ab by 5 for all a b, comma b belong to a. Check whether star is commutative or associative. Next part is find the identity element for star and inverse of a belong to capital A if it exists. Now for the commutative part, let a comma b belongs to a, then a star b equal to 3ab by 5, and 3ab by 5 means 3ba into 5 by 5 obviously, because multiplication is commutative. Usual multiplication is commutative, so a into b, you can write b into a, and this should be b star a. So a star b equal to b star a for all a comma b belong to a, and this shows that star is commutative on a. Now associative part, let a comma b comma c belong to a, then a star b star c equal to a star b means 3ab by 5 star c, and this should be 3 into 3ab by 5 into c by 5, and after simplification we got 9abc by 25. And next, a star b star c is equal to b star c means 3bc by 5 according to the definition, and equal to 3 into a into 3bc by 5, and after simplification we got 9abc by 25. So a star b star c equals to a star b star c for all a bc belongs to a, and this shows that star is associative on a. Now identity element, let e belongs to a be the identity element in a, then a star e equal to a for all a belong to capital A. It is a definition of identity element. So a star e means key. So a star e means 3ae by 5 equal to a. A cancel out since a not equal to 0, as a belong to capital A and capital A is q minus singleton 0. So a not equal to 0 obviously. So e should be 5 by 3. And 5 by 3 should belongs to capital A, that is non-zero rational number. Now for the inverse, let b be the inverse of a in a, capital A. So a star b equal to e means 5 by 3, put it. So a star b means 3ab by 5 equal to 5 by 3. So after simplification we got b equals to 25 by 9a belongs to capital A, as a not equal to 0 obviously, and this belongs to a because it is a non-zero rational number. So thus for every element a belong to a has the inverse 25 by 9a belongs to capital A. So now problem number 4. Consider the binary operation star on the set 1, 2, 3, 4, 5 defined by a star b equal to minimum of a comma b. Write the operation table of the operation star. Now the operation table is like that. So there are how many elements? 1, 2, 3, 4, 5. So first of all, write the operation is what? Star. Write the operation here, star, and all the elements from this row, first row. So 1, 2, 3, 4 and 5, and write all the elements in the first column. Now you can see that I'm writing all the elements on the first column and on the first row. So now a star b, that means 1 star 1, how much? 1 star 1 means a star b means what? Minimum of a comma b. That means 1 star 1 means minimum of 1 comma 1. What is the minimum? Value is 1. Got it? So now 1 star 2. So minimum of 1 comma 2 is what? 1. Minimum 1 star 3. That means minimum of 1 comma 3 is 1. So similarly, now 1 star 2, minimum of 1 star 2 is 1. You should write 1 here. So now this is your operation table. See that minimum of 3 comma 1 is 1. minimum of 3 comma 2 is 2, minimum of 3 comma 3 is 3, minimum of 3 comma 4 is 3, minimum of 3 comma 5 is 3. Similarly, minimum of 5 comma 3 is 3, 5 comma 4 is 4. This is your operation table. Clear? Now problem number 5. A binary operation star on n is defined by A star B equal to LCM of AB for all AB belong to n. Number 1, examine the commutativity and associativity of star on n. Find the identity element in n, and now the next one is also find the invertible element in n. How to solve it? So clearly A star B equal to LCM of A and B. So B star A equal to LCM of B and A. We know that for any A comma B belong to A n, LCM of A and B equal to LCM of B and A. So A star B equal to B star A, which proves that star is commutative on n. Now for the associative part, for A comma B comma C belong to n, we have A star B star C. A star B means LCM of AB star C, means LCM of this one and the C, obviously. So LCM of what? ABC, number 1. And again A star B star C. So A star LCM of BC, and this one means it's A star, this one means what? LCM of A and this one. Okay. So this means what? LCM of ABC. So from 1 and 2 it follows that star is associative on n. Clear? Now for the identity element, let E belong to n be the identity element in n. Then by definition of identity element we have A star E equal to A for all A belong to n. Now A star E means what? LCM of A and E. Okay. Now look at that. LCM of A and E is equal to A when it happen if E is 1. Look at that. LCM of 4 comma 1 equal to 4. Obviously LCM of 4 comma 4 is what? 4. LCM of 3 comma 1 is what? 3. LCM of 5 comma 1 is what? 5. So similarly LCM of A and E is A if E equal to 1. So 1 and this one belong to the natural numbers. So this 1 is the identity element in n. Now for the inverse, let B belong to n be the inverse of the element A belong to n. Then A star B equal to E, identity element which is 1. And so LCM of A and B equal to 1 means what? A and B are equal. That's why LCM is 1. Got it? So A equals to B equals to 1, which shows that 1 belong to n is the only invertible element in n. Is that absolutely clear? So now for the exercise 1.5. Number 1 is the binary operation star on R given by A star B equal to A plus B by 2 for all A B belongs to R commutative. Number 2, part 2 is the above binary operation star associative. Number 2, let star be a binary operation on Q given by A star B equal to 2A minus B whole square for all A comma B belong to Q. Find 3 star 5 and 5 star 3. Is 3 star 5 equal to 5 star 3? Question mark. Now question number 3. Let star be a binary operation on Q defined by A star B equal to AB by 7. Show that star is commutative as well as associative. And number 2, it has 7 as identity element. Number 4, every non-zero element is invertible. If A not equal to 0 belong to Q, find its inverse. Number 4. Let star be a binary operation on Z defined by A star B equal to 2A plus B minus 3. Find 3 star 4. And number 5. If the binary operation star on N defined by A star B equal to A to the power B, find 2 star 3, 3 star 2, 1 star 2 star 3, 1 star 2 star 3. Question number 6. Let star be a binary operation on N defined by A star B equal to LCM of AB. For all AB belong to N, find 5 star 7. Number 7. The binary operation star from R cross R to R defined by A star B equal to 2A plus B. Find 2 star 3 star 4. Number 8, show that the operation star on Z defined by A star B equal to A plus B minus 2 for all AB belong to Z is a binary operation. Number 2, satisfies commutative and associative laws. And number 3, find the identity element in Z. Number 4, also find the inverse of an element A belong to Z. And number 9, a binary operation star is defined on R minus 1 by A star B equal to A plus B plus AB for all AB belong to R minus minus 1. Discuss the commutativity and associativity on star of star on R minus minus 1. Find the identity element if it exists. And number 3, prove that every element of R minus minus 1 is invertible. Okay, it is your homework.